For circle P, we are asked to solve the values of x and y variables. But you can notice here that x is represented by 3 different segments. This is the first segment from this point here towards this external point. Same here, but it has additional value, but x can be used to solve this measurement from this point to the same external point. And finally, we also have the measurement of this chord from this point to this point, represented by x plus 13. After we could solve the value of x, we might also share or here another method that could relate in solving for the value of y, which is represented by this chord here. If you can see, all of these 3 segments here are considered to be secant segments. And using the secant-secant power theorem, we can solve the measurement of any unknown segments relating to the measurement of the segments cut by the secant and the first point of intersection. For this, let us use first the secant segments containing x so that we don't have any confusion later. Just like this. This is the first 2 secant segments. Removing the third secant segment here containing y so that we could isolate a process that could solve only for x. So let me try to increase it here. Okay. Now, for secant-secant power theorem, it tells us that for the product of the entire secant segment here, so this is the entire secant segment, so that's x plus 13 plus another x, because it's the entire secant segment, times the exterior segment of x is equal to the product of the same situation on the other secant segment. It's the product of the entire secant segment, not just this 12, but it's the entire. So it's actually 12 plus x plus 2 to be multiplied by the exterior secant segment x plus 2. So we might see here multiple algebraic processes that will involve in solving the value of x. So for this is actually just 2x, sorry, that's x, 2x plus 13 to be multiplied by x equal to, the combination of this is x plus 14, that's 14, 12 plus 2 times x plus 2. So let me add a little bit space or more space, since I believe it will constitute longer process. Here we apply distributive property, so we'll have 2x squared, sorry, that's x squared, pardon, that's 2x squared plus 13x for your left hand side. For your right hand side, you'll be using FOIL method. X times x is x squared. Okay, that's x squared. Then plus x times 2 is 2x. Plus 14 times x is 14x. And 14 times 2 is 28. Now we could transpose all of this to the other side to come up with one general quadratic equation later, or in quadratic equation standard form. You have 2x squared plus 13x, then this becomes minus x squared minus 2x and minus 14x minus 28. That's 28 equal to is 0. So let's try to simplify this. 2x squared minus x squared is just simply x squared. 13 minus 2 is 11 minus this, so you will have minus 3x. Again, let's check. This 13x minus 16x, so negative 3x. And you have here minus 28 is equal to 0. Now that we have this quadratic, we can solve for the value of x here. So we could have this factor, x, and another x here. So you will have 28. That's negative 28. So you will have 7 and 4. Specifically minus 7 and plus 4. Let's check using the FOIL method. X times x, x squared. X times 4 is 4x. Negative 7 times x is negative 7x plus the 4x earlier, so negative 3x. And negative 7 times 4 is negative 28. That's correct. So you have two values for x using zero factor property. Your first value for x is 7. The second value for x is x plus 4 equals 0. So you will have a result which is negative 4. And since x is a measurement, so we only use the the positive value of 7, not the negative. So x is 7. So this is actually 7. This should be 9. And this is 20. Okay? So you could check also using mathematical computation. We have here the entire second segment is 27. Again, that's 27 times the exterior. So 27 times 7. More or less, that's 49, 189. Okay, that's 189. Let me check. 7, 7, yeah, 189. For the other one, the entire, not just 12, 12 plus 9 is 21 times the exterior of 9. So it's still equal to 189. That means this is really correct, and we have solved the value of x. Now, since we are done with x, we can now solve for y. But it depends on us which of the two second segments may be used. Let me use this given figure. I'm using this first second segment here. We know to be 20 and 7 because x is 7. So this should be 20 and this should be 7. And since this is also a second segment, we know, okay, we could use the other values. So you have here the entire second segment. So you'll have y plus 9, and that's the entire second segment, times the exterior, which is 9. Let me move this computation here. And probably, again, extend this here. So this is a long process since it involves multiple relationships. Okay, you have this second segment, y plus 9 times 9 is equal to 27, not just 20, it's the entire second segment, times 7. So we can have here 9y plus 81 is equal to 189 here. So 9y is equal to 189 minus 81 is 108. And when we divide both sides by 9, y should be equal to 12. So we are going to use here again 12 units. And here as well, 7 units. But before we end, let's try to check if it's really 12 by substituting here. So if this is 12, okay, 12. So the entire second segment here is 12 plus 9, which is 21, times 9 here. So it will just still result to 189, which is just the same as this. So we have now solved y and x by isolating some important segments of given circle P.